Hello, so last night you guys did an ed puzzle that went over some examples introducing the remainder theorem. So what I'd like you to do now is I'd like you to try the examples that weren't done in last night's video on your own from pages 8 through 11. And then after you've tried them on your own, I'd like you to play this video and see how you did. So you could hit pause, try the examples, and when you're done, just play the video and you can check your work. Okay, so number 14. Now, number 14 gives us this function, p of x, and they want to know what is the remainder of p of x when we divide by x minus 5. Now, we've already done long division. We could use long division and we could determine the remainder, but the remainder theorem is faster, right? It's a shortcut. It says rather than dividing by x minus 5, we can substitute all of these x's with the 0 that corresponds with this factor. So we can substitute all these x's with positive 5, and whatever p of 5 is equal to would be our remainder. Okay, so again, instead of doing long division, right, that's a lengthier process, we can plug in positive 5 into our function, and this right here, when you plug in positive 5, is equal to 240. So our answer for number 14 is choice 4. Okay, on the next page, number 17, is x plus 2 a factor of this expression? So if we did long division, right, if this were to divide evenly into this expression, it would be a factor. If there was a remainder, then x plus 2 would not be a factor. So instead of doing long division, let's substitute, since this is x plus 2, let's substitute all our x's with negative 2, and let's see if we wind up with a remainder. Okay, so when we substitute all these x's with negative 2, okay, then we determine what this is equal to. It's equal to negative 5. So this negative 5 would be our remainder if we had done long division. So if there's a remainder, it means that x plus 2 is not a factor. So you can either say what I said here, x plus 2 is not a factor of the given expression because it does not divide evenly into the expression. You could also say x plus 2 is not a factor because there is a remainder. So if that's easier for you to say, here, let me put that too. Okay, so if you prefer to say this, x plus 2 is not a factor because there's a remainder, see right here? That's the remainder. That's totally fine as long as you show all of this work. Okay, number 18. Number 18, given r of x, they first want us to find the value of r of 2. So all we're doing is we're replacing this x with a 2. Okay, so when we do, we wind up getting r of 2 to be equal to negative 6. Now, I'm just saying you don't actually have to show any of this work. If they give you a function and they want you to substitute the x with a 2, you can just write what I have boxed off here. You could write off r of 2 equals, and you could just write its value. Okay, part B says, what does your answer tell you about x minus 2 as a factor of r of x? And then they want you to explain, so make sure you explain. Okay, well, because we have a remainder of negative 6, right, it means that x minus 2 is not a factor. So I just said x minus 2 is not a factor of r of x because r of 2 does not equal 0. You could have also said that x minus 2 is not a factor of r of x because, same reasoning up here, there is a remainder. So either answer would work for part B. All right, let's take a look at number 19. Okay, so number 19 says when g of x is divided by x plus 4, the remainder is 0. Okay, so the remainder theorem says that instead of dividing by x plus 4, can't we substitute in a negative 4 for this x? So this is telling us that g of negative 4 is equal to, well, whatever the remainder is. They're telling us the remainder is 0. So this is telling us that g of negative 4 equals 0. All right, well, actually, look at this. Choice 2 says it right there. So that is our answer. Okay, so 21 is similar to the one that we just went over, but they're kind of giving it to us in the reverse order. So they're giving us p of x, and they're saying that p of negative 3 equals 0. So if p of negative 3 equals 0, doesn't that mean that if we were to divide p of x by x plus 3, then the remainder would be equal to 0. So they're saying that if we were to divide p of x by x plus 3, okay, there would be no remainder. So let's think about it. If there would be no remainder, doesn't that mean that x plus 3 would have to be a factor? So look at that. That's what choice 4 says. X plus 3 is a factor. So choice 4 is our answer. All right, let's take a look at number 23. If x minus 1 is a factor of this expression, what is the value of k? All right, well, if x minus 1 is a factor of this expression, doesn't that mean that if we replace all of these x's with positive 1, right, the opposite sign of what's here, this expression would be equal to 0? Okay, so again, if x minus 1 is a factor, it means that if we replace all the x's with positive 1, this expression should be equal to 0 because there's no remainder, right? If something is a factor, it means there's no remainder. All right, so all we have to do is just solve this for k. All right, so we know that 1 cubed, 1 times 1 times 1 is equal to 1. We know that 1 squared is equal to 1, so this is negative k times 1, which is just negative k. And then 2 times 1 is 2, so plus 2 equals 0. All right, so now if we combine our like terms, 1 plus 2 is 3. So we have 3, then I'll bring down the minus k, equals 0. Now it's actually faster just to move this k to the other side of the equation, right? Because that would make it positive. So you could just take it and move it. If it's a negative k on this side, when you bring it over here, it would be a positive k. Or if you want to show this, which you definitely do not have to, right? Plus k and plus k. These will cancel, so I bring down the 3. And 0 plus k is k. So k is equal to 3. Choice 3. All right, number 24. Determine for which polynomials x plus 2 is a factor. Explain your answer. Okay, so we actually have to try it for both of these because it could be one of the polynomials or it could be both of them. That's why they put this little s at the end. So we have to figure out what p of, remember, negative 2, we plug in the opposite sign. So let's figure out what p of negative 2 is equal to. And then when we're done, we're going to figure out what q of negative 2 is equal to. Okay, so I'm okay if you want. You can use your calculator. It's up to you, but we're going to replace all these x's with a negative 2 and see what we get. Okay, when we do, for p of negative 2, that's equal to 60. And for q of negative 2, that's equal to 0. Okay, now remember, these answers represent a remainder if we were to have divided these functions by x plus 2. So what that means is x plus 2 is not a factor of p of x because there's a remainder. X plus 2 is a factor of q of x because look at that, there is no remainder. Okay, so I just said here that x plus 2 is a factor of q of x, right? I said because q of negative 2 equals 0. You also could have said because there is no remainder. Either one is fine. And then I said x plus 2 is not a factor of p of x because p of negative 2 does not equal 0. See, p of negative 2, it does not equal 0. Or you could have said because there is a remainder. So either one is fine. All right, let's look at the next page. And those are the last examples we're going to look at today. Okay, so for the examples on page 11, we're going to be looking at graphs instead of being given equations. Okay, so 25. So they give us here the graph of f of x, right? And they want to know what is the remainder of f of x when it's divided by x plus 4. So if we're dividing by x plus 4, right, we want to figure out what is f of negative 4. Okay, well, this right here, negative 4 represents an x value. So we're going to go on the x-axis to negative 4 right here, and we want to know what is the y value when x is equal to negative 4. All right, so let's think about this. The coordinates of this point are negative 4, 0. So when x is equal to negative 4, isn't y equal to 0? Okay, so this is going to be equal to 0, which is choice 3. All right, let's take a look at the ones below. So here they give us a function, f of x, and in part A they want to know what is the remainder when f of x is divided by x plus 2. So if we're dividing by x plus 2, we want to substitute this x with a negative 2. So we want to determine what is f of negative 2. All right, so let's look on the graph. We're going to go over here to negative 2, and the graph is all the way down here when x is equal to negative 2, right? The coordinates at this point would be negative 2, negative 6. So when x is equal to negative 2, the y value is negative 6. So it means that f of negative 2 is equal to negative 6, which is choice 3. Okay, letter B. What is the remainder when f of x is divided by x minus 2? So for this one, let me just change colors here. For this one, since we're dividing by x minus 2, we're going to plug in a positive 2 for x. So we're trying to find f of positive 2. Okay, so let's look on our graph. We're going to come over here to positive 2. And if we follow it down to the curve right here, we see that when x is equal to positive 2, the y value is equal to negative 2. Okay, so our answer here would be negative 2. So that is choice 1. All right, and then finally letter C. What is the remainder when f of x is divided by x? All right, well, let's think about it. X is the same thing as x minus 0 or even x plus 0. Okay, either way, whether it's a plus 0 or a minus 0, aren't we taking 0 and substituting it in for this x? So we're trying to find, actually let me change colors again on the graph. We're trying to find f of 0. All right, so let me scroll back up to the graph here. So when x, let me scroll up a little more. When x is equal to 0, let's follow it down to our graph here. Isn't the y value negative 6, right? This right here, the coordinates of this point, would be 0, negative 6. So what that means is that f of 0, that's our input value, is equal to negative 6. That's our output value. So let's come down here and write f of 0 equals negative 6. So that would be choice 3.